Welcome back, programmers. We will now start Chapter 3 of our textbook, Structured Program Development. So this is the beginning to making our programs have control, more than just spitting out some information to the console. We now want our programs to start making decisions based on, say, user input. Next slide. So this chapter is going to cover the beginnings of algorithm development, some concepts such as pseudocode and flowcharts, and we're going to introduce our first control structures, things that let us control the program. In particular, this chapter does the if-else statement, and the while iteration statement. We'll pick up a few other things along the way. I'll learn a little bit more about formatting our programs, both the input and the output and the data, whether it's an integer or a number with a decimal point in it. So we'll do a little bit more of that too. So the procedure for solving any computing problem is a procedure for developing an algorithm. Your textbook kind of generically says that you have to consider actions and the order of the actions. Well, I thought that that was not sufficient enough information for you to really develop good habits on how to develop a program. So in my opinion, from experience of programming myself, as well as I read this in another textbook, so hey, the proper way to go about solving a computing problem and developing the algorithm is, number one, either draw a picture of the problem and do a sample calculation. Make sure you understand the problem on paper, what you want it to do. Step 2 is write pseudocode. We'll talk about pseudocode in a moment with examples, but right now pseudocode is kind of an informal English language way of describing what you want the program to do. So it's sort of like if you can express the program in English words, you understand it, you're able to now put it down on paper. Step 3 is make a flow chart. That may or may not be necessary. On small programs that we tend to do, at least in the first half of the semester, you really maybe don't need to have a flow chart, but it's a good practice to get into. If your program has to make a lot of decisions, a flowchart is an excellent idea to do. The step 4 is to actually write the code, and then step 5 is to test the code with known data. So give it a sample calculation for which you know the answer to. So let me give you examples. Here's an example of pseudocode. Well, first, let's say our problem is to calculate, we want to write an algorithm that calculates the area of a circle from the radius of the circle. So our pseudocode might be something like, we want to get the radius, we know the program, we want the algorithm to get the radius of the circle, then we want it to calculate the area and then display the answer. Pictorially, since I'm pretending to do it on paper right now, we see that R is an input and A for area is an output, and then there's a calculation in between. So here's the code that actually would do the next step. Step 4 is to write the code. This problem was so simple that I didn't do the flowchart, but we are going to talk about flowcharts coming up. So step 4 is to write the code. There's kind of a lot going on in this code that I will point out more as we go through this lecture. But one of the first things is noticing that I haven't declared ints, I've declared doubles. So double is a type of floating point, it's a floating point data type, meaning it can have a fractional part. It can have a decimal or it can be displayed as an exponential. So I want to allow decimals, so I've declared it as a double. And I've used capital P, capital I for pi because it's a constant in this program. Our coding style says make constants be all capital letters. So then I've also declared a double called radius. Why? Because maybe the radius of my circle is 3.2, something with a decimal point. So I don't want it to be an integer, I want it to be a double. Then, of course, our programs should always be user-friendly, using good English, giving instructions to the users. So I have a printf, please enter radius of the circle, and then the scanf, where the user enters the information. So notice here textbook hasn't talked about it very much yet, but there's a whole chapter coming up on this kind of thing, that I've used %LF. LF means long float. It means I have a decimal number and high precision. My %LF, my % long float, matches the fact that I'm using double right here for radius. So I get the user input, I store it in a memory location with an identifier that I've called radius. That's what the next line is. And then next, print the area is, and here's another funny new thing that I've thrown at you. I say %.4 LF. So LF again is long float. Long float matches the fact that I've used double as a data type. The .4 means that I am going to allow the answer, when it displays to the console, I'm going to allow it to show 4 significant digits past the decimal point. So it's saying how many digits to show. And then, so printf, and then here's the calculation. So notice again, pi is capitalized. Puts is good if you just want to do a text thing, so I used puts. And making it user-friendly, I said press any key to exit. So I tell the user to enter and press any key to exit the program. This is important. It is important to make the program user-friendly. And then the last thing, well, not the last thing, 2 other things to note about this program is that I have 2 get characters. I will talk more about that later. It has to do with something that's hidden at the end of this. It has something to do with the new line that's up above here on this line where you got the user input. So you've already used up 1 get character by that factor. So I have to have 2 get characters to keep my console window open. When you compile the program, test it. If your program is compiled and I double click on it from the Windows environment and it flashes a black screen for a moment for console window and then closes, you know that you need another get character in your code. I can give you an example of that in a little later in this video. There was one other thing to point out about this piece of code. The last thing I want to point about, some people have asked about this. I could have just said main void with empty parentheses right here, and the program would have been fine. And we'll learn more about this when we learn about functions, because main is a function. But I've said int main void, but because I've declared int, it says that this function, this main function, has to return something to the computer. And I really am not returning anything to actually the computer, to the operating system, so I'll say return 0. But this says that I have to return an integer, because I put an int there, and so down here I've put a return 0 statement to make it work. If you take off int and take off return 0, you can do main and then empty parentheses here by itself. So a few people have asked that question. So a lot going on in that program. That program does not come out of your book, but it has features that will help you with this chapter. So now let's get into the meat of the chapter, which is our control structures. Control structures control the flow of the program, or in other words, the order in which steps are executed. Whether that means the program makes a decision to go and execute one piece of code, or the program decides to execute a different piece of code. There are basically 3 types of control structures. One is just a sequence structure. That's just basically saying the steps are executed one after another. That's just our sequential execution that we've been doing so far in our programs. And then there's a selection structure. In this chapter, we'll cover if and if else, but there's also a switch structure. So that means that the program will make a selection depending on some test it does. We'll have an example in a moment. So this chapter covers if and the if-else selection structure. And then there's also an iteration structure. That's usually something that tells the program to do something over and over again until some condition is met. In this chapter, we'll cover the while structure, and the next chapter will cover do, while, and for. But this chapter will cover while iteration structure. So let's start before we do some examples, let's talk about the flowchart, because I told you I would talk about the flowchart. These are symbols for a flowchart. Some of the symbols, there are more than this. You can probably Google it and see that there are a lot more symbols. But for now, these are the symbols that we're going to work with. This elongated, rounded corner rectangle thing in peach color is called a terminator. And this little piece of code describing a flowchart describing some code, the terminator might say start, and then the other terminator might say exit. Process is a rectangle. The colors are arbitrary. I just made them colors. So a rectangle is a process. The process in the example we had so far might be to do calculating the area of the circle. So process might be area equals pi r squared. Decision. Decision has to do with our if and our if-else structures that we're going to talk about. A decision might be if area is greater than 10, do something different. Or I don't know what the decision will be. Well, I'll show you some decision examples. So this is some test that has to occur. Some condition has to get tested in a decision structure of the program. So let's look first at the if selection statement, which we got actually exposed to in the last chapter, but we're going to formalize it now. My example problem is, or my pseudocode is, if the student's grade is greater than or equal to 60, print passed. So a little snippet of code that I have right here, if grade greater than or equal to 60, puts passed. Little few things, going to talk about that little snippet here in a moment. Please notice it's if, then it's parentheses for the test, what the condition is that you're going to test. In this case, grade greater than or equal to 60. If that evaluates to be true, then what's in the curly brackets gets executed. In this case, it puts passed to the console. So if this condition turns out to be false, the thing in the, if this test evaluates to false or a 0, then the commands that are within the curly brackets are skipped, and the program execution continues after the curly brackets. So this is the flow chart for it. We have a dot, just a little circle here, because this is a piece of the code. It's not, I don't have the entire code here. I don't have the start and exits terminating structure, so it's just a piece of the code. This selection statement is called a single entry, single exit structure. I enter the statement, or the selection statement, at one point, and there is only one exit. The exit is either true or false. It cannot be both. It will not do both of them. So there is a single exit to this structure. Next, let's look at the if-else statement, and then I'm going to look at actual code and a few things about style with this code. So this is the if-else selection structure, because as you probably guessed, you would rather have a piece of code that says do something if the statement is true, but do something else if the statement is false. And that's what the if-else will do for us. So my pseudocode, if the student's grade is greater than or equal to 60, print passed, else print failed. So here's the code. If, in parentheses, this is the test. The test is grade greater than or equal to 60. If that evaluates to true, do what's in the curly brackets. Curly bracket, curly bracket. Else, if the statement evaluates to false, do what's in these curly brackets, puts failed. So these comments, these green comments that the author puts in / end if and then end else, these are for your benefit. Please don't put them in your code. This is the author trying to give you extra information about what's happening in the code. Coding practices, coding style, you would not print these comments. These comments are for you to help understand the code. Where you are required to have comments, you are required to have comments in your preamble of your program. Let me pull up example here. You are required to have this preamble information, tells you the programmer, the date, and what the program does. You are required to have that. And if you write your own functions, your function is required to have, this is a block comment, your program is required to have line comments describing what the function does. Now, main is a function, but main is also a keyword function. Main does not require line comments before it. It is the only function, well, it's not the only function. So the keyword functions do not require you to put line comments to say what this function does. Main is main is main. Everybody knows that's the main program. So anyway, I wanted to look at, before we come back and look at this, let's go on to the next slide. So I think if-else is pretty self-explanatory. This is the flowchart for an if-else statement. You enter the selection statement right here. It's either true or false is your outcome, and then after it evaluates one or the other, the program flow will continue. So let's go back to where I was a moment ago. Let's go back to my Notepad++, this program. So instead of having snippets of code, I'd rather see a complete piece of code, so I did. I set the student's grade to be a 70, int grade equals 70. It's an int right now, it's not a double, it is an int, there's no decimal point. So I used an if-else structure. If grade is greater than or equal to 60, puts passed, else puts failed. A few style things I want to note about this program. One is what the body of the if structure, the thing that's in the curly brackets, it is indented. Notice that puts is indented. Same thing with the else part of it. The part that's in the curly bracket is indented. This helps the readability of the program. There is an alternative style. This is the style your author uses, which is very acceptable. I actually have my personal likes, but you don't have, you can do what the author does because that's your textbook. My personal likes is showing it this way. This is my personal style preference, especially as the ifs or else gets bigger. Right now, puts is only if this condition evaluates to true, puts passed is the only thing that happens. It could be that I have multiple statements in here. I sort of like seeing my curly brackets aligned with the indents. My personal preference, you can do either the author way or this way, and either way is acceptable. So the other little interesting thing about this code is that C++ has an operator called a conditional operator. It's kind of a shortcut for the if-else statement, although if-else to me is more readable than the conditional operator shortcut. But here's an example of the conditional operator on line 19. I have a thing in parentheses. This is the test, the condition that has to be tested and evaluated to either true or false. Grade greater than or equal to 90, true or false. And the conditional operator is the question mark and the semicolon here. That constitutes the conditional operator. So test, grade greater than or equal to 90. If it's true, puts A to the screen. Notice there's no semicolon after it. If it's false, puts it's not an A to the screen, and then there's a semicolon. This is kind of a shortcut notation. It's called a conditional operator. You'll have to remember the syntax. If you put a semicolon in there where it doesn't belong, of course you're going to get a compiler error. So you may have guessed or read ahead that you can also nest the if-else statements, which is what we're going to do right now until we learn a better way. And you can test for a whole lot of conditions. So here's some pseudocode that that is an example of what we want to do. If the student's grade is greater than 90, you print A. Else, and you have to continue testing, if the student's grade is greater than or equal to 80, print B. So notice if A is true, you will already have printed A, and you will not do the else part, because that's if A is false, then you do the test for B. And then if B is false, you'll do the test for C. So the way the author has it in these grade-in boxes is showing explicitly the indents before we actually look at the code. So you have an if and a test and something to do, and an else, and they are aligned in this block right here. Same thing with this next if-else statement. They show alignment, at least pictorially, in the block, and so forth and so on. And until you finally get all these other conditions. A wasn't true, B wasn't true, C wasn't true, and then D wasn't true. And if none of those, A, B, C, or D, are true, then you're going to print that the student has an F. So these are nested if and else, and this is what the code actually looks like. So a few things to point out about this code right now is, one, see the if and the else that goes with it are aligned, and there is an if in parentheses, curly brackets for what to do, and then an else and curly brackets here and here for what to do. This is really important, that else the curly brackets are here and here. So if it's not an A, then you're going to test and see if it's a B, and so I have a nested if here. But this next test for the B grade, if it's greater than 90, remember this doesn't get evaluated if it was already an A. So if B is true, put a B. Else we're actually going to go on to another test. So I want specifically for you to notice the alignment of the curly brackets and the if-else statements. If-else aligned, if-else aligned, if-else aligned, if-else aligned. Really, 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 really important. Now, our comments: end if, end if, end if, end if, end else, end else, end else, end else. Please don't put that in your code. That is your author trying to, again, make sure that it's clear that you understand. When I'm looking at this, it's cluttered up, in my opinion. So, okay, let's go on to an alternative to these nested if-elses. An alternative, but absolutely equivalent way of writing all those nested and indented if-else statements is to use the if, else if, else if, else if, and then the final condition has to be an else. This is a little cleaner form of doing the same task and the same selection structure. It's cleaner looking, it avoids the deep indents of the previous way. So, but the important thing to note about this one, it has to be an if, and then it's an else if, but the final test has to be a pure else. It's the final, if this isn't true, this isn't true, this isn't true, this isn't true, this is the last, all the other ones evaluated to false, so this is the last condition left. So this is cleaner, easier to follow, in my opinion, and typically more liked by programmers. I will mention that this one is exactly equivalent to the other example, and you're probably saying, wait, the curly brackets aren't the same. And that's because if you only have one thing that happens, you actually don't even have to have the curly brackets. The next line of code is what's evaluated. So I have else, and the next thing would be in curly brackets. But it's only one line of code, so you don't actually have to have it. Let me give you a further example. We're starting to talk about what's called a compound statement. So your compound statement it must be enclosed in curly brackets. So if grade greater than or equal to 60 didn't actually have to have curly brackets, because if that's true, the next line of code is going to be evaluated, which puts passed. But it's good programming practice to put those curly brackets in anyway, even if there's only one line of code. Else, what's going to happen if the test evaluates to false is in curly brackets, and you have to have the curly brackets here because two things happen. You're going to put failed to the console, and you're going to put another statement to the console. In this case, you have to have the curly brackets, and this is what's called a compound statement. So your next section in your textbook, section 3.7, is the while iteration statement. This is also called a while loop. We will actually cover 3 different types of loops, but this chapter is going to cover the while loop, and in the next chapter I think we get the do and for loops. And they are subtly different. Not subtly, but they are different, but they can accomplish the same task, and you might use one over the other for various reasons that we will talk about. So here's an example of using a while loop. Here's our example is find the first power of 3. So remember, you're going to do 3 times 3 times 3 times 3 times 3, however many times it takes until you get an answer that's larger than 100, because they're products of 3. So my little snippet of code, I've initialized product to be 3, and then I'll say while the product is less than or equal to 100, that's the test. While that is true, the product is less than or equal to 100 is true, then I'm going to multiply times 3 again. I'm going to up the product. And then at the end of this loop, after I execute this statement, I'm going to go back up here to where the while is and do the test again. Is product less than or equal to 100? If this is true, I'm going to multiply it by 3 again. And I'm going to stay in this while loop until the test evaluates to false, and then I will exit the while loop. Here's the flow chart of what's happening. You enter the test. If it's true, I'm going to do a calculation, and then I'll come back to where the while statement test is and test again. And I'll keep going through this loop iteratively until the test evaluates to false, and then I will exit the loop. Little bonus information not in your textbook coming up. The while loop is one of the 3 loop structures that we're going to study. While is this chapter, do while is next, and for is next. And this is, as an outline, a structure of the 3. You may want to refer back to this slide in the future, and I'm going to post this on my PowerPoints on Lalima so you can refer to them. Right now we're talking about a while loop, and the basic structure of the while loop is while condition, the test, do some statements, and then you do the statements while the condition is true, and when the condition is false, you go to the next, you exit the body of the while loop. This is called a pre-test loop because the test happens before you execute something. Do a test, do a condition, evaluate true or false, then do something. So it's called a pre-test loop. Next chapter we'll visit a post-test loop and another pre-test loop. So now let's go ahead to the next section where they're going to start doing some case studies. As we do these case studies, some other features of our programs will come out. And then, yeah, okay, so let's go ahead with some case studies. The first thing is the example, it's on page 80 of the textbook, but figure 3.6, it's a problem where you have to calculate the average, the class average, but that you are limited to entering 10 grades. So there's a counter that says that you have to enter 10 grades, and then it's going to find the class average. So that's the first example in your textbook. So I looked at the example in the textbook, and it's very commented up. It's actually right here. Here's the example in the textbook. So I have it now in my Notepad++, and I can see all of the comments here. And to me, it's very hard to look at, to point out some features, but it's to help you follow the program. That's why it's so commented up. In a moment, I'm going to clean it up how I would expect it to look when you turned it in, and then I'm going to show you a few shortcuts, and then I'm going to talk about a few features of this program. So I did not retype all of this myself. At the beginning in chapter 1, the author talks about that you can download the examples for yourself, and you can. So I'm just going to point that out to you right now. I think the author said you go to ditel.com/books slash, I think he has it slash something with the 8th edition. And then you'll get this page on the internet. And the examples that the author does are all located here where it says, let me make it bigger, download the code examples. So you'll get a zip file with all of the examples that the author does in his textbook, and then you can open up the examples, extract the zip files, open up the examples for yourself, and look at them in living color in your Notepad or whatever editor you're using, rather than looking at the colors online or on your textbook. So you can open it up and see the code examples for yourself from the author's website that he talks about in the beginning of chapter 1. It's actually, I just had that page open a moment ago, but in chapter 1 he talks about where you can get those additional resources. So I didn't retype all of his examples. Sometimes I retype them because I want to, or I don't like something about it. But in this case, I took the example from the zip file that I extracted of all the examples. So you, of course, have to have the header information. You do not have to have a statement that says function main begins the program execution. I think you guys probably do know that by now, that that's the place where the program execution begins. You should only have one line of white space here before you enter into the program. So one of the things is that we have to initialize the while loop before we enter the while loop. It's a pretest loop. So this counter is the number of grades that we will be allowed to enter into this averaging program. So that's the number of grades to be entered. That's a counter. But I'm going to clean it up a little bit. Sometimes you need a definition. I mean, obviously, int grade is a grade value. Do I really need a comment to tell me that grade is grade? No. Total. Sum of grades entered by user. That's kind of okay. Average of the grades. That's kind of okay. But nevertheless, I'm going to clean it up like maybe I want you to turn it in. And then there's an initialization phase. This comment is here for your benefit, but it doesn't need to be here and something you turn in to me. And so it initializes things, and it says total equals 0 and counter equals 1. Now, I could have done that up here. I could have said counter equals 1, I'm initialized. Total equals 0, okay, I'm initialized already. More efficient. Remember, being efficient is part of your grade in your programs. So that's more efficient. Okay, this next is the processing phase. This comment is here for your benefit to tell you what's going to happen. It is not what you would turn in to me or turn in as a professional program. Whether or not you have a line of white space here, that's up to you. I kind of like to initialize all my variables, then go to the meat of my program and leave a white space there. No right or wrong answer there. Okay, so now I have a test. While the counter is less than or equal to 10, I'm going to do some calculation. The moment counter is equal to 10, I'm going to exit this while loop and go to the end of what happens after the curly brackets. Now again, way too many comments in this program. Let's clean it up. It's obviously that a printf enter grade is prompting for input from the user. It's obvious what a scanf is doing. Add the total to the grade. The way I named my variables, total equals total plus grade, the variable names tell me what's doing. I don't need to say total equals total plus grade and I'm adding grade to total. That is, like, way too much texty fill stuff. So there. And then increment to counter. We're going to learn more about incrementing here shortly. So counter gets incremented by 1. Yes, this curly bracket is the end of the while loop. Okay, looking more clean and readable already. So when the counter gets incremented by 1, the counter started at, what did the counter started by 1. Is 1 less than or equal to 10? Yes. Do what's in the statement. Increment counter. Counter is now 2. I go back to the beginning of the while loop. Is that less than 10? Yes. And I keep going. Finally, counter becomes 11. 11 is not less than or equal to 10, the test says, and the program execution will jump down here to what was called the termination phase. That comment is there for your benefit. I personally would not put a line of white space right here. I'm outside the curly brackets. The indents tell me enough of what's going on. So then the average is total divided by 10. I am dividing by an integer, which means I will not get a fractional result. I will get a rounded off integer result, which I don't like, but we'll fix that. And printf is still part of this main body of the program. Yes, class average is. Clearly we are displaying the result. That's too much comments for me. And this is the end of the main function. That's clear by the alignment of the curly brackets. So now here's the whole program without a million comments to clutter it up. And so I think you can see better what's happening with the program. I also showed you that you could initialize things in the program when you declare the variables. This is an unsigned int, meaning it won't have positive and negative. I will talk more about the fact that it's being unsigned int. This program would have worked just fine if you declared it as only an int. So I'm good with declaring it only an int, so not confusing the issue. Okay. So other feature of this program, this printf statement. Notice I've used this format specifier with a %s. That means %s. Ooh, that's a little bit tricky. Enter grade. Oh, because, oh, never mind. It's not. This is enter grade is a string statement right now. And you're using a format specifier s for string, so it will print string. I could have just as easily as said printf enter grade. I didn't need to use a format specifier string, but this was a roundabout way of introducing that you can have a format specifier for a string. C does not allow you to, I can declare a character data type up here, but I cannot declare a string data type. So we will talk more about that later. These are all ints. Int format specifiers are either i's or d's. There is a subtle difference about i's or d's that we learn about. It's actually in a couple of chapters, but I might just show it to you in my second YouTube for this chapter. So a D or an I here is okay if my variable type is a int. A float is not right now. And then total gets total is assigned total plus the grade, so it's summing up all of the grades, and then it's incrementing the counter and going back to the test. Average is total divided by 10. You will get an integer result. As I said, it will be rounded off. You will not get the decimal result. And then finally printf average, and once again I'm printing an integer, so a D or an I right here are acceptable format specifiers. The D can actually give you some more freedom with how you specify the output than the I, but that's for down the road somewhere. So I compiled this program now that I cleaned it up to be more readable to me, and I'm running it right now, executing it right now. Enter grade 88, oops, enter grade 88, 93, 80, 72, 65, 99, 100. I'm just making up numbers. And it tells me what the class average is, and the program exits. So it exactly only wants to take 10 inputs, but program runs as we expect it to. So now let's make it better. I'll include this cleaned up code looking like how it should look like when you turn it into me. I just put it in the PowerPoint, so it'll be on Laulima. The PowerPoint will be on Laulima, so you can look at the cleaned up version example. Okay, so moving on to improve the program. Obviously, to improve this program, you want to be not limited to averaging 10 grades. You want to average however many grades you need to average. So one way to do that, and it's not the only way, but it's the way we're going to cover right now, is to use what's called a sentinel value. That is a dummy value, also called a dummy value or a flag value, but it's a value that indicates that it's the end of the data entry. In our case, reasonable test grades are 0 to, or reasonable grades are 0 to say 120 or something. Maybe there's extra credit. But a -1 is not a reasonable test value. So let's say the program asks for grades, asks for grades, asks for grades. But if you enter a -1, the program says, oh, I'm done now. Here's your average. So that's exactly what we're going to do. Here's the textbook example with a million comments once again. That makes it hard for me to follow. At least me personally, it's hard for me to follow. Maybe you guys like all those comments. It probably has its helpfulness. You're still going to, once again, it's declaring counter, grade, and total. This time we're doing something also a little bit nicer and allowing the average to be a decimal number. So if the average was 76.5, we're going to get 76.5. So we're going to use this data type called float to calculate the average, even though the grades are being entered as an int, and total is, because it's the sum of the grades, is still an int. We're going to allow the division part to give a decimal answer with this float data type. So they still initialize with zeros. This time the counter initialized to 0, which was a little different. So print instructions to the user, so enter grade or -1 to end the program. So that's the prompt this time. And then of course the user enters a grade and it's stored in this variable whose identifier is grade. So loop while the sentinel value is not yet read from the user. That's the next step. And so this time we're saying, well, grade is not equal to -1, then you're going to get the total, new total, and increment the counter. So you are keeping track of what counter is doing. Counter was initialized as a 0 this time, and the first pass through this while loop, it's going to become 1. So the user did not enter a -1. The user, the first pass, entered some grade, and counter automatically was, from the program, incremented to 1. So it'll do that however many times it needs to do that. We're still in the loop. So one of the things I don't like, let me clean this up so it's more readable, because you don't want, clean this up. You don't want to put a white space like this right in the middle of your while loop, because everything is enclosed in brackets. You know, prompt for the user input, that's just not necessary. Read next grade, end while loop. Okay, so I'm in the while loop. Let's just look at the while loop. So while you have not entered the sentinel value, so the user did not enter -1, you're going to get a new total. Initially, the first pass, the total is 1 grade. You're going to up the counter by 1. You're going to prompt the user, enter another grade, -1 to end, and you're going to, oops, yeah, okay. And you're going to prompt for the next grade. And you're going to keep prompting for the next grade until the user enters a -1. So once again, this is a pretest loop, so you had to enter the prompt before you ever entered the loop the first time. So there it was. The prompt had to be given to the user before you ever entered this while loop for the first time. And then now we've exited the while loop because the user has entered a -1, and it says, my goodness, I'll leave that for a minute. So here's another new trick with this program to introduce. So if the counter wasn't equal to 0, meaning you have at least one grade in there for your average, right? So counter was not equal to 0, then the average is the total divided by the counter. Now, this little part in front of it is a casting. We've just casted the answer into a decimal number. So we've changed an int divided by an int, but we've forced it to be a floating point number. So a number with a decimal point in it. And then print the class averages, and I introduced this once already. It says 0.2f, it's not long float this time, but 0.2f for float, and that means display it with 2 significant digits after the decimal point, and it has to be a floating point number, not an integer, and display the average. Of course, this curly bracket is the end of this if statement. So notice again, curly bracket, also called a brace, is aligned with the if statement. Same thing with this else. There has to be a curly bracket aligned with the else. If no grades were entered, output this other message. So if no grades were entered, counter was equal to 0. So this is a refinement of the program. It's actually much nicer because you can enter as many grades as you want. If you're done, you press -1 to enter. So this section of your book also introduces this concept of top-down programming or top-down algorithm development. So let me talk about that for a moment because it is a concept that's important. So let's talk about that. So top-down programming with the stepwise refinement is a way of starting with looking at the program from a high level and then breaking it down into smaller chunks. So this breaking it down into smaller chunks and tasks could could eventually in a very large program end up being chunks of code that you hand out to different programmers, and then all these chunks of code will then come back together into one solid piece. But you start at the top with what the program initially has to do, and then you start refining it and breaking it down into tasks. This becomes more especially important later when we introduce functions. So you could, for example, have somebody else work on a function that has to go into your program, and then the program could call the function. That would be an example of breaking down the program. So in our case, the very top starting point, if we're going to do a top-down programming approach to tackling a problem, is top from the very top, high level. We want to determine what the class average is for a quiz. Then we go to its first refinement of and to first pass to first high order thing. What might this program do? It might have to initialize variables, it might have to collect some inputs and do some counting, and then it would in the end have to calculate and print class the results of the program. So that's your first refinement. Then your second refinement to this program is, and I'm actually going to pull up your textbook instead. The second refinement might be something like being more detailed. You're starting to name your pseudocode now is starting to name some of your variables. Initialize the total to 0, initialize the counter to 0. Then progressing to the inputs that you have to input. Now we start to think that what iteration structure might be needed by the program. Remember, in ours right now we're using a while loop, and it's called an indefinite loop because we don't know how many times it's going to execute. It's indefinite. It's waiting for that sentinel value. So now we start to see that you're going to need a while structure as we write our pseudocode. So this is the second refinement. That's probably really there's one more refinement. We have to be very careful about one thing that happens in the program. We have to be careful about testing for the possibility of a divide by zero. Divide by zero would be a fatal error in our program, and it would cause the program to fail, also affectionately known as crashing the program. So let's look at our second refinement. Although I showed it before as more like pseudocode, now I sort of put the pseudocode into sort of a programming format, and you start to see where the sections of our code might be. The second refinement is the one I already showed you. Anyway, this is what it would look like if you would run the program. I just until you enter the Sentinel value, the average is not computed. So let's talk a little bit more about the float and some of the data types that we used in this program. So I'm going to talk about this explicit conversion that occurred right here. It took an int divided by an int and it forced it to be a decimal. One of the things about the order of evaluation, the precedence, and any of these assignment statements that you make, the order of precedence, like the multiplication and division, comes before the addition, subtraction, etc. I gave you the whole precedence list. Barring that, the last thing that's considered, that is the thing to the right, right side of the assignment operator is evaluated before the assignment to average. So everything to the right is evaluated before the assignment to average. And even more importantly, total divided by counter is evaluated before being assigned to average. Now what happens with this float statement is it temporarily creates a location in memory where total divided by counter will be stored as a floating point number. So that's what's called an explicit conversion. I want to show you a few other examples because the opposite is an implicit conversion, but this conversion between data types can really mess you up. So let me show you some examples. I have a piece of code here, and look at it carefully. I have 2 divided by 3. These are both int values, and I display the result as an int. So what do you think will happen in this case? Well, in this case, the answer is 0.666667, but I have an int divided by int, so I can only have an int as an answer. And furthermore, my format specifier says display an int as an answer. So here I tried something a little trickier. I have an int divided by a floating point number. So this is an example of an implicit operation. So the answer will be a floating point answer. But then my format specifier said display an int answer. So let's see what happens when I execute this code. And in my third line example, I have an int divided by a floating point number, but I actually specify that the output specifier, format specifier, is actually a floating point number. So when I compile and run this code, this is what I will get. I will get 0, a nonsense number, and the correct answer is the third answer. Let me just save that for you for a moment. This is what the answer will be. I'll put it back next to the code so you can see it well. Oh, this doesn't work in here. Okay, never mind. Okay, so this first answer, actually what I'll do is make it so you can see it well, side by side. This was the answer, and this is the code snippet that we're looking at. I'll put them side by side so you can see them side by side. There we go. So the first answer, 2 divided by 3, gave an int answer. It had no choice but to give you 0. The format specifier says give me an int answer. It gave you 0. The second line, 2 divided by 3.0, is an implicit, not explicit conversion. The answer was a floating point number, but my format specifier said int, so it just gives you the garbage of whatever's stored in memory at that point. Give you a garbage answer. And then the third line is actually the correct way to solve that problem. I could have said 0.2 F if I only wanted to see 2 significant digits. I could specify that. So, but this is still an example of an implicit conversion because I do have an int divided by a floating point number. The bottom line in all of this is to make sure you should really make your data types match your data type declarations match your calculations during the program, and also match your input and output format specifiers. There's one more topic I need to cover in this textbook, and I don't like my YouTubes to run over an hour. So I think I'll make a second YouTube, part 2, to cover the remaining topics of this chapter. And I also want to give you some more examples of these data types and format specifiers because it will help you in the program when you do your programming assignments. Okay, bye for now.